Okay, in this video we'll see that how sound is produced by human. Speak loudly for a while or sing a song or buzz like a bee. Put your hand on your throat and what do you feel? Any vibrations? Yes, in human the sound is produced by the voice box or the larynx. Put your fingers on the throat and find a hard bump that seems to move when you swallow. This part of the body is called as the voice box. It is at the upper end of the windpipe. Two vocal cords are stretched across the voice box or larynx in such a way that it leaves a narrow slit between them for the passage of air. Here you can see. Are you able to see the narrow passage where the air can move? Right? So this is the part which is called as larynx, right? And this is how we can speak, right? Voice box in human, this diagram you have to draw. When the lungs force air through the slit, the vocal cords vibrate, producing sound. Muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of voice is different. Similarly, from that when they are loose and thick, the voice is different. This is how the vocal cords function. Take two strips of the same size, place these two pieces one above the other and stretch them tight. Now blow air through the gap between them. As the air blows through the stretched rubber strips, a sound is produced. You can also take a piece of paper with a narrow slit and hold it. Now blow through the slit and listen to the sound. Our vocal cords produce sound in the similar manner. You can do this activity at home and you can see how the sound has been produced, how your vocal cords are working. Right? Now sound needs a medium for propagation. How is it possible for the vibrations to move? Without medium it is not possible because the sounds waves move in the form of vibrations. The vibrations move in the form of waves, and the way to travel these waves, the medium is needed, right? So when you call up your friend who is standing at a distance, your friend is able to hear your voice. How does the sound travel to her? Now here you can see the activity 13.7. Make a metal or glass tumbler. Make sure that it is dry. Place a cell phone in it and ask your friend to give a ring on the cell phone from another cell phone. Listen to the ring carefully. Now surround the rim of the tumbler with your hands. Put your mouth on the opening between your hands. Indicate your friend to give a ring again. Listen to this ring while sucking air from the tumbler. Does the sound becomes fainter as you suck air? Remove the tumbler from your mouth. Does the sound becomes loud again? Yes. Can you think of an explanation? Is it possible that the decreasing amount of air in the tumbler had something to do with the decreasing loudness of the ring? Yes, because the vibrations will be less if the air is less. Indeed, if you had been able to suck all the air in the tumbler, the sound would stop completely. Actually, sound needs a medium to travel. When air has been removed completely from the vessel, it is said that there is a vacuum in the vessel, and that is why the sound cannot travel through a vacuum. Similar activity has been done over here. Take a bucket or a bathtub, fill it with clean water in activity 13.8, and you can place a bell inside the water and still you will see that the vibrations can move through water also. So there is one more activity to show you that how the sound waves travel. Take a meter scale or a long metal rod and hold it from one end to the other end. You can see the if one is scratching at one end, the other end you are able to hear the sound. That means it travels through solid also. So your sound waves are traveling from all the three matters, solid, liquid and gas, but from the solid it travels faster. We find that sound can travel through wood or metal. In fact, sound can travel through any solid. You can perform the interesting activity to show that sound can also travel through strings. This you can make at home. At one end of the string, at both the end of the string, you can tie some box or something like that, matchbox or something, and you can play a telephonic conversation with your friends. Can you say that the sound can travel through the strings? Yes, it can. Similarly, we hear, next topic is we hear sound through our ears. The shape of outer part of the ear is like a funnel. When sound enters, it travels down a canal at the end of which a thin membrane is stretched tightly. It is called the eardrum. It performs an important function. To understand that the eardrum does, what the eardrum does, let us build a tin can model of the eardrum. See here, it has been done in activity 13.10. Take a plastic or a tin can, cut its end, stretch a piece of rubber balloon across one end of the can and fasten it with the rubber band. Put 4 or 5 grains of dry cereal on the stretched rubber. Now ask your friend to speak hooray, hooray from the open and observe what happens to the grain. Why do the grains jump up and down? It is only due to the vibrations of the rubber band, right? So this is how your eardrum works, that when the sound waves travel through the funnel like structure of your ear and reaches the eardrum, your eardrum starts vibrating, right? The eardrum is like a stretched rubber sheet. Sound vibrations make the eardrum vibrate, and the eardrum sends vibrations to the inner ear. From there the signal goes to the brain. That is how we hear sound, right? So draw this structure, it is very important, okay, of the human ear. Next part we will study in the next class.